Welcome to John Park's workshop. It's me, John Park, here for Adafruit Industries, and we are in the shop today, ready to make some stuff, talk about some projects, look at some MakeCode things. What else have we got? I got a product of the week. I got a little project that a friend of mine made using the product of the week. A lot of cool, fun, interesting stuff for all you makers out there and people who like to watch stuff getting made and explained. You're in the right spot. We'll be hanging out over on Discord. If you're wondering where the chat is, that is that. That's Discord right there. Hello, Mr. Certainly, Matumble, Mark, Jim, C. Grover. Nice to see you all. And I'll also keep an eye over on the YouTube chat. So if you want to stop by and say hi, do it. If you got questions, ask them. If you have thoughts and comments, suggestions, things that you're looking to talk about, let me know. One thing, actually, an impromptu thing, one thing I want to mention, an announcement that I didn't set up a graphic for this or anything, but I can grab something real quick on the internet. There is a very exciting Miami Maker Faire happening this weekend. It starts tomorrow, so it's Friday, Saturday, Sunday, 14th through the 16th. I'll be doing a talk on the 15th. Let me pull up the site. In fact, let me open up a browser here that you can see. And it is just Maker Faire Miami is what I was searching. There it is, miami.makerfaire.com. There's the info. It is free. You got to go and register, and I believe it's all being handled through a app. I think it's called Hoovy. I might have that wrong, but there's a sort of application and platform for doing virtual conferences, and that's what's being used. You'll be able to use it for chatting and asking questions. And in fact, if you look through either the speakers or the agenda, you can find, let's see, let me see if I can just put in my last name here. There we go. You can find a session. You can browse through stuff. That's the session I'll be doing. And that's going to be at 3 o'clock Eastern time on Saturday, August 15th. And the talk, it says there, in the workshop with John Park. And I'm going to be doing a kind of behind the scenes of this place and this show and other stuff that I do in here. So if you've ever wondered about how I've got the shop organized, where things are, why they're that way, I've got a camera I'm going to be moving around with and talking about stuff, different tools and equipment and parts and things. And I'll also talk a little bit about how I actually run this show or how I do video shoots and editing when I do pre-edited videos like the AdaBox videos. So that'll be coming up this Saturday. There's a lot of really excellent speakers who are going to be doing talks. There's also some panel sessions that are that look really exciting. I know that Sophie Wong and Jen Shack-Attack Schachter and Ali Weber and Liz Clark and at least one other person who I'm Estefania. I think they're going to be doing like a session, like a panel session that should be really good. I shouldn't just say things like that without looking at the names first because I was so bound to forget one or screw one up, but I think I got it. Anyway, go check that out and take a look and see what stuff you wanna go hear about at the virtual Miami Maker Faire. It was just a year ago, last year, that I went to the real Miami Maker Faire, which was fantastic, in person in Miami. But this one will be online, and if anyone can do this well, it is the crew behind Miami Maker Faire. They're excellent, so I encourage you to go check it out. Let's see, what else? Let me pop back in with the Discord. Yes, there will be Sophie Wong and Blitz City DIY, for sure. They're there. So, and I know that Liz, Blitz City DIY, is doing a talk right before the time slot I'm in, I believe, and it's going to be about some of her projects, including or specifically the robot xylophone. So that should be really cool. All right. Let's see. Next up, let me mention our job board. If you are looking for work or if you're looking to hire someone, head on over to jobs.adafruit.com. You can see here, this is the job listing section. It's free to post jobs. It is free to post your resume and info, so go there and check it out, and you might find some work. Product of the week. My product of the week this week, I actually have been bummed because these have been out of stock for a while, but they are back, and it is the Trinket M0. One of my favorite little microcontrollers, and the Trinket M0 costs about $9. It's ATSAM D21 chip on there. It's got the analog, one analog in-out. It has a couple digital in-out. You can do serial with it. It has a little dot star LED built right on for RGB color indicator. And one of the really cool things about it is that it does USB HID stuff. It can act like a USB MIDI device. So there's a lot of interesting stuff you can do with a tiny, tiny little chip, little board. And that actually leads me into my gear report for the week, because my friend and yours, Todd Kurt, recently built a little module that's based on the Trinket M0, and I'm going to go ahead and demonstrate it over here at the workbench. Let me switch over to this bench cam, and you can see right here there's a module that's new in my little cigar box rack here. This is a synthesizer, Eurorack synthesizer, and this is it, the Trinket trigger right here. I'm going to zoom in on that. And as you can see, it has a Trinket, it has a Trinket M0 built right into the top. It actually sets into some female headers, so you can take that off, program it as usual. And what this does is essentially gives it power from the Eurorack power supply through a voltage regulator. We have a couple of resistors to protect plugging two outputs into each other. And then there's these two outputs, the B and A. B is used for sending a gate pulse, and A is used as a control voltage that can vary. And how do you trigger them, you may ask? Well, these are capacitive touch pads here. The B and A are using 2 pins in capacitive touch mode. So with this patched into other stuff, I can now tap B here, and you can see it's triggering. And I can tap A, that's triggering 2 different pulses sending out. Let me turn on this speaker here. I thought that was on. I thought we were going to hear a big sound there. Here we go. You ready? Oh, she's talking to me. She says, power on. All right. You ready, lady? Here we go. All of that based on a lovely little Trinket right there. Although she thinks she's turning off. Is she out of power? Okay, I'm glad she lasted that long. So that runs a CircuitPython, pretty simple CircuitPython script. And I don't even think it adds any libraries based on beyond the typical CircuitPython install. If you head over to GitHub and look up ToddBot Trinket Trigger, and I can put that link there in the Discord if people are interested. Oh, Todd's already put it there. Okay, he put his Twitter status there. Hi, Todd. Yeah, so this is the module, and you can get the board file and schematic. It's all open source and readily available. And you can see that in the firmware section here is this Trinket trigger.py. This is a CircuitPython script. And there's actually a feature not being used, I think, in the version I have on there that also uses that button that was at the top of the module there. Sorry, I know the focus is terrible. That's a little momentary switch there that's not coded to do anything right now, but that uses another digital pin and a pull-up resistor so that we can in the panel silk screen, it says record, so there's an idea of recording some of your button presses and then letting it to loop through those. So that is my gear report with the very cool Trinket trigger. Todd says, is it one of the simplest Eurorack modules? Perhaps it is. A very lovely module. And like I said, if you head over to the Discord chat, you can ask Todd any questions you have about that module there. And of course, that's just one example of the great versatility of a tiny little microcontroller like the Trinket M0 running CircuitPython. It doesn't have to get all elaborate and Euro-rack synthesizer-y on you. You can do simpler things than that, but I thought that one was pretty exciting. And oh yeah, by the way, I should mention, in the PCB there's just a couple of traces and pads of copper on the PCB under the solder mask that are used for that capacitive touch. So all of that touch stuff is capacitive touch, and it works really well. So nicely done, Todd, and thank you for the module. I will have a lot of fun playing with that. All right, let's see. What else have we got? I'm going to take a sip of water. I'm going to take some delicious topo. I love that effervescent Topo Chico. We're not sponsored by Topo Chico, by the way. Let's see. What's happening next? This is probably a good time for the MakeCode Minute. Let's do it. All right, let me bring up the Chrome browser here and get set up. And I'm also going to pop in a little, let's throw a down shooter on there. How about this one for a moment? I'm going to move that over here. Bear with me. There we go. So, for the MakeCode Minute today, I wanted to build essentially a pitch pipe for tuning a ukulele. Now, this is not a tuner in that it's not going to tell us when we have the right notes, but it's instead going to give us a reference pitch so that we can then tune the strings by ear. So here's my daughter's ukulele. And when you want to tune those strings, you want to know what those notes are. I think it's G, C, E, A. So what I've got is this little Circuit Playground Express, and I've added a speaker just to make it a little louder, a little amp speaker. And when I press the A button, it's going to cycle through those notes for us. So let me bring my mic closer so you can hear that. And then if we want to just play one of those notes while we're tuning, we can use the 4 capacitive touch pads here. You can see that I accidentally hit 2 at the same time, and it tried to play them at the same time, which caused the speaker to make a lower, weird buzz sound. So you got to be a little careful about that. So let's take a look at how I built this in MakeCode. You can see here I have an array that I build on start that is the array of my 4 pitches. There's my little note to myself, G, C, E, A. So these are those pitches in hertz. And then I have a variable that I created called note, and that's essentially which string we're on, which note we're playing. And then I set a pixel color to pink on the first pixel of the ring. And here you can see every time we press the A button, I first blank the pixels, turn them black. Then I set the pixel at the current note to pink. I play a tone at whatever this pitches string has in the place of the current note. So initially that's 0. When we are done playing it, we then increment that variable note by 1. So it essentially means we're moving to the next string for the next time we use this. And then we're also using this modulo remainder of note divided by 4 to loop through 1, 2, 3, or 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. The individual touch pads are done using this input touch A4, A5, A6, and A7, and they do the same thing, but it's a little simpler because they just explicitly say play pitch 0, 1, 2, or 3. And you can do it inside of the simulator here, and you can even test out those touch pads. You won't hear that right now. But if I use my real Circuit Playground Express down here, you can use those to tune up your uke. And that is your MakeCode Minute. You'll notice that there's a trend here. I often run out of ideas of what I'm going to build for the MakeCode Minute, and then I go to my daughter and ask, and she always comes up with really good, simple idea. I had some very overly complicated thing that was a pain, and I was getting frustrated with it, and I asked her, and she's like, how about a ukulele pitch pipe? I said, okay, that's perfect, nice and easy to do. So I appreciate her input on these things. Let's see, how about we take a look at a MakeCode arcade game pick of the week next. So I'm going to, again, bring up my Chrome browser here. And my game pick of the week is called Wall Jump Hero. And I got this on the MakeCode forum, so forum.makecode.com in the arcade channel. And this is by Dreadmask197. Let's take a look. Here's the game. And again, the frame rate is slow on my playback the way I have this set up, but it's a nice buttery smooth frame rate for me while I'm playing, and it will be for you too when you check it out. So here is the game, and it says this is a wall jumping game with falling damage. So I'm going to press the space bar for A, and you can see I can now move with the D-pad, and I can jump. And you'll see when you hit a wall, this hero stabs his little short sword into the wall, and it causes the fall to slow down. There's a regular fall, and there's a wall jump fall. And now you can combine this into a really nice gameplay mechanic for traversing this vertical, really tall level, which I really like. I thought this was a cool design. Reminds me of that Micro Mages game that we looked at a couple weeks ago. And it's a really fun mechanic. All you do is move towards the wall, and it slows you down if you can hit it with your sword. So if we take a look at the code here, it's actually not a lot of code. It's done very nicely in just a few blocks. So I encourage you to go take a look, check out how it works. The primary mechanic is inside of one of these two on-game update blocks. And this one is essentially checking velocity, just seeing, are you up or down? So are you moving upward or downward? And are you moving towards the left or towards the right? And then it's doing a wall check. If it detects that the sprite is hitting a wall on the left or on the right, then it will engage the proper animation sprite and adjust the velocity so that you fall slower while the sword is pushed into the wall. So really nicely done. That is my arcade game pick of the week. It's Wall Jump Finisher by Dreadmask197. Go check it out. I also think that could be really nice. That demo, like so many things in MakeCode Arcade, it would be a great thing to look at and consider how to use it in a different type of game. In a different game, you might be able to leverage some of the ideas there, which is one of the great things about all of the sharing of the code that goes on inside of MakeCode Arcade. All right, let's see. What's happening next? You saw me look around to find out what time it is. Well, this is what's happening next, is our project this week, which is a clock. And it's a nice big one. So I would have mounted this up on the wall, but I'm still picking it up and doing things with it, and we'll look at the code on it and so on. So I don't have it mounted yet, but eventually I think I'm going to mount this maybe just behind my workstation. I like having clocks. I've got a lot of them. This is the second one now in my life that is going to use internet time to stay accurate. I have the one that I built, and I showed this off just, I think, last week. And this is the clock from C. Grover, which is using the 7-segment displays. I've got a short power cord on it. So this one uses a Feather M4 and a real-time clock module. And you can set it manually, but then the real-time clock module and its little battery keeps things accurate. This one goes and every hour checks the internet time. And so you can see I'm using a matrix display. It's 64 by 32. I have a Metro M4 Airlift. That's the one that has the Wi-Fi coprocessor. I use a ESP32 as the Wi-Fi coprocessor. And then I also have the RGB matrix backpack that makes it easy to send the data to the pixels for how to light them up. And it also, you can see I've got a couple things plugged in here. This USB cable is not plugged in to anything at the moment. What I will do is this thing just doesn't draw a lot of current because I'm not lighting up many pixels at once, so I can drive it from a little USB battery pack. I'm not sure for how long, I haven't tested the current draw, but that just makes it easy for me to pick it up and move it around and talk about it and explain without needing to have it resync the time. So there I've got, these sometimes come on these modules. It's these little threaded standoffs that have magnets on them. You'll probably see I can set it here. Can you see the back of, what can you see the back of? This, yeah, I can set it on my workbench. Are you seeing that? Yeah. So I've set that on my workbench there, which is steel. Click that on. They're pretty strong magnets, and this thing doesn't weigh a lot. So that wouldn't quite work with the amount of microcontroller I have there. Flush, wouldn't be able to stick that on your refrigerator probably, but I thought it was interesting to show. And I've got some of our LED plastic on here. Right now I don't have anything fancy for holding it on. I'm just using some gaffer's tape in the corners to keep that on there. One way I've been using this is with a wire stand. We have these little wire stands, and that'll set the clock in there, including the RGB LED plastic. So let's. What I'm going to do is I will plug this into USB on the computer, and that way when I change things we can see them. I'll point a camera at it as well. So let me pull that battery pack out of there. And while I'm doing all this talking, it's probably a good idea for me to glance in at Discord and see if there's any questions. Let's see. No? Good? We're all good. Okay. There's some discussion about insurance fraud going on. I'm going to avoid that one. Okay, so now I've unplugged it, so it's lost power. And what I'll do is plug in, I think I'll just plug in USB for data. Pull that off of there. And I'll do an overhead camera for you to see the display. Let's see if I can angle that there real quick. Let me switch to this. Okay, so you'll see when it starts up, it just goes to a default 12 o'clock. And now what it's doing is it's trying to get onto my Wi-Fi access point and find the internet time. So what I'll do is I'm going to bring up another little window. Let's do this Atom window here. And actually, you know what? I'll use Moo because I think that'll be a little easier to see. It's a little bigger. Okay, so I'm opening up a serial port on here. I'll pull power. And now I'm plugging that back in. It should say it finds a new device. Yeah. And if we watch the output down here, provided it's the only thing I've got plugged in right now that's got a serial port. Okay, so it says could not connect to internet. Retrying in 3 seconds. So my access point is a little bit far away that I'm using for this. So, and I think because my base station has multiple meshes, that sometimes is a little finicky for it to jump onto at first. So what I'm going to do actually is just kind of hold it up in the air to see if I can get it to get that signal a little better. Oh yeah, it's really not connecting. All right, let's be an antenna together, shall we? I'm gonna put my head on my hand. That works, right? Oh, still not Come on, you can do it. I'm sorry, I should set up an access point inside of the workshop here. This one's out in the other building. This is scintillating TV, I know. Actually, also going to plug in the DC power onto it. Why not? I guess I shouldn't have messed with it. It was a good thing I had my battery pack in there. And actually, we haven't tested yet what the accuracy is over many hours. We think that it stays pretty tight over an hour, so that's how it's set up to check the time. All right, I'm going to restart this and see if that helps. Open that serial port. And while that's, okay, it looks like it's, no, that's the first thing. Okay, the first thing it's doing is it's checking my secrets file for my time zone, just to report which time zone. I was testing this by putting in New York as well because I wanted to make sure things were working. So that's just a reminder to me. And what I'll do is I'll load in the code.py. There it says Metro minimal clock. All right, crossing fingers. It's connecting to, says it's trying to connect to my access point. And what I'll do here in a second, so you don't have to just continue to watch me hold this and hope, is I'll start going over the code. So let me set this down. We'll talk about the code. You can keep an eye on it there. If it does get our time, then you'll see that change to my local time, which is about 1:30. So what happens here? We're importing some libraries, including time, so that we can use the time both for checking time as well as counting seconds. We have the board being imported, so we have the pinouts, the display I/O, and terminal I/O. Terminal I/O actually I'm not using it except for when I'm in debug mode. And terminal I/O is essentially a font that's built in so that if we have problems with our bitmap font, we can go into debug mode and just use the terminal font. The Adafruit display text is what we're using, actually the label subset of that, to create the text that you're seeing. I'm importing bitmap font so we can use a BDF font. And then I'm bringing in these two libraries, Matrix, or this one library, Matrix Portal, both the network and the matrix sections of it. And these are convenience libraries, stuff that is similar to the PyPortal libraries that Melissa's been working on these a lot to make life easier when you want to connect to a network, when you want to get the time, when you want to display to the matrix as well. So you can see here I have a function called blink, and I've set that to true, so we'll see blinking of the second hand when it's connected. By the way, I'm going to do something here. I'm going to move this. I'm going to hook up my battery pack again and move this a little bit over in the workshop where I get a better Wi-Fi signal. And then I'll use this as a reminder myself. I have to reconfigure the router that is in here to give us some Wi-Fi because I'm just connected directly. All right, so I'm taking power off of there. So now I'm just, I'll put this back here maybe, so you can see that. All right, you can see that behind me there. We'll check in on that every once in a while. Let's see, can I put that somewhere you'll see it for sure? Maybe not. You know what? Point this camera. Like so. It won't be in focus, but at least you can see it when I'm not blocking. There we go. Here's the debug mode, and when I use that, like I said, it goes to terminal font. It gives us some feedback about the text location. I was using that just to place things nicely. Then we go and check for our Wi-Fi details. So those are kept in a separate file that's on the board called secrets, and that way people aren't sharing that around a lot. It's the same method we used with PyPortal. And that will allow us to put in the SSID of the access point as well as your Wi-Fi password. I'm setting my location for time zone in there, as well as my Adafruit IO name and key. And that's what we're using to grab the time. So there's a time server on Adafruit IO. Next, we set up the display using typical display IO stuff. I've got some color presets that I've made. What this will do is during the 6 a.m. to 6 p.m., I have it in green-ish, and then for the evening hours, it goes to red. And that's how we designate sort of the two halves of the day. Not necessarily AM, PM. I think I said that yesterday and realized that's not true at all. It's not AM, PM, but it's more when I want like daylight green or I want nighttime red. Then we'll set up the typeface. So if I'm not in debug mode, my font is equal to a bitmap font that we load. And I'm using this one that I'm crazy about. It's IBM Plex. This is the kind of official typeface of IBM that was created back in 2017 or 2018. And it has a really nice mono font that can be used for your terminal, if you're coding, for anything you're using where you want your typeface to be monospaced. And the reason that's important here is that if it's not, whenever the time changes, I'm going to restart this. Whenever the time changes, you'll get a shifting of the spacing, even the colon, if that was a space versus a colon, if these aren't monospaced, you'll see things wiggling around a lot. So we want them to each occupy their own space. You could do more, you could do individual labels per character to get around that if you wanted a non-monospaced type, but I like the look of this one. I like the way it. Okay, so then you can see when I'm in debug mode, it will grab the terminal I/O instead. I can show you an example of that in a second when we hook this back up. And then the clock label is created. It has a maximum of 6 glyphs in it. You actually only need 5, so we have the 4 digits and the colon. But I think the space may count as 1, so I think that's why I set it to 6. And that I'm using a space when I'm not showing the colon, when we're blinking. You could also probably do something with, if you had separate labels, you could do color instead. But the way it's set up right now, the individual labels are going to have the same color as each other. So all those characters have the same color in this usage. And then we get to this. This is the time updating. So this routine goes and it grabs local time. And then it splits up the answer into the hours and the minutes so that we can display those properly. And then we also have the blink routine in here. If we're in blink mode, then it will show and not show the colon or the space in alternating seconds. And then we finally display that clock label. So that gets broken up into these variables that we grabbed, the hours, minutes, and colon, formatted like this. And then I have the positioning, so the bounding box can actually be calculated. Label has this routine called bounding box, and it finds the X, Y position of, I think, the lower left corner, as well as the height and the width. And that's useful so that we can then place it halfway down and halfway across. This is the Y, actually. So halfway down the display, so display height divided by 2, and then the display width divided by 2 minus the width of the bounding box puts its center at the center, which is really cool. When this, oh, what's it doing now? Is it getting the time, or did my battery run out? This is a disaster. I swear this was working well. Yeah, that battery pack died. Whee! All right, let's. I'll hook it back up over here, and we'll cross our fingers that we actually get the time. Clearly, that is one issue. Is when you're first booting up, you definitely need an internet connection for this to work. So you could probably make a more sophisticated version that used a real-time clock and a battery and didn't have this problem. But we're keeping it simple. So just plug that back in. We'll see if it ever manages to find its way. And then this is the routine that's running all the time. So this is the main loop of the program. If the last check is none or, oh look, it found the time, so it did connect. This message here is not correct because I didn't reopen my serial port, but Good. It connected. We just didn't get to see it say it connected. Oh well. I'm not going to attempt it and try it again just now. And you can see there it's doing its little blinky, blinky, blinky. The routine checks to see if the last check is beyond an hour ago. So this is 3,600 seconds. And so that's how you could adjust this if you found that it wasn't accurate enough for you, or you didn't need it to check as often. You could tune that. So when it does find that it's an hour has gone by since the last check, based on counting the time monotonic versus the last check time, it's sort of like a timestamp, then it will run this update time routine. It also shows the colon. We just didn't want it to go to blank while it was checking, because that can take a moment. So it'll always display the colon there. You might see it hold sometimes while it's checking. The time is still accurate, but the blink would look weird. And then we network using the matrix network library get local time. This is all sort of wrapped up inside of that matrix portal library. It knows how to go check your secrets .py file to grab the Adafruit IO key, go up to the internet, ask Adafruit IO for the time, and then convert it to your local time. So for me, Los Angeles time. And that is it. That is how that works. I'll now tempt fate by changing something in this and hitting save, and we'll see if it gets my internet connection or not. So we'll turn blink off. So I'll say blink is false. And I created this, I should say Melissa created the code for this. I just tuned some things. Oh yeah, see, it got on my network just fine that time. I just tuned the graphics, but big thank you to our own Melissa for creating the code here. And then as I kind of envisioned what I wanted to look like, I decided I didn't want always blinking because sometimes that's distracting to me. So I created that feature here. And then I went and found a very specific type. I mentioned IBM Plex. I found a very specific typeface that had the look I was after. And then I hand-tuned some stuff. And I want to show you a little bit about how some of that stuff works. So let me, let's pop over to, I'm going to show you in Photoshop something for a second. So let me put on some glasses so I can see some smaller typey thingies that I'm going to show you. How about here? Yeah, I need to launch something, if you'll bear with me. I'll peek over at the Discord chat. Yeah, yay, nice job. Mr. Certainly says to Maker Melissa, absolutely amazing work, thank you. All right, so I'm gonna open up a couple files here and then I'll share my Photoshop session window. How about, yeah, there we go. We'll do a screen capture, new screen capture. It's taking a moment. Sorry, so that something's happening. Oh, there we go. Okay, so it's brought up a screen capture that's a black hole. And I'm going to change that to be a window. And pick Photoshop, there we go. And I'm going to hide that MakeCode. So let's drag this over a little bit there. Hopefully this will play nice. So here in Photoshop, this is kind of the look I was going after. So this is a 640 by 320 pixel document, so it's 10 times larger as far as pixel count than our display. But I used this to just mock up how things would look. And I noted the type size. This is 240 point type here. So when I created a one-to-one scale document, you can see here, this is a 64 by 32, 64 pixel wide by 32 pixel high document. You can even see Photoshop will put in little lines to let you know where individual pixels are. If I go to a pencil tool, for example, this is like drawing pixel art. So you can, whoops, let me make a new layer. So you can see, whoops, I made a giant one. So you can see there's individual pixels being drawn. And by working out the size of the type here, especially with looking at how big it would be when I have 4 digits on there, this tells me the size of typeface I'm going to convert or size of font I'm going to convert the typeface to. So what I did is went over to, and again, I'm going to, if you'll bear with me, I'm going to share, I might just share this screen because I think there's a chance that this will be multiple windows that'll be hard to share otherwise. So let me create another screen capture. I'm going to show you FontForge, which is an open source font application that allows you to take you can create fonts in it, but it'll also allow you to, yeah, that'll work. Okay, so let me get things centered up in here. So this is FontForge, and right now it doesn't have a font loaded, so you just see these empty positions for individual glyphs, as they're called. So what I'll do is I'm going to open up that font that I had picked. So let's go to project folder for Metro. Whoops, that was not a... That doesn't work, huh? That's weird. Or did I rename it? I might have renamed it. Let me find the matrix. I think it's just called matrix clock. Yeah, there it is. No, not that one. Good, I got there. Okay, so here's the font as downloaded, and this is a free to download font from IBM. You can also get, I found it initially on Google Fonts search. And I liked the one called IBM Plex Mono Medium. So I'll open that one up, and there's the font. And now what you can do is either take the whole thing and convert it, or you can pick individual glyphs that you want if you're trying to fit, in a very, very small space. So I could just grab 0 through 9 and the colon there, or you can pick the whole thing. And then you convert those strikes. So I'm going to take these and turn them into bitmap strikes, which is essentially stamp down the Bezier curve mathematical description version of this into individual pixels, turn it into pixel art basically. And now I know I want that at 24 point type because that's what worked in my Photoshop grid. So I'll click OK. I'll then regenerate those glyphs just because. I have no idea why you do it that way in this software, but you do. And then I will go to File, Generate Fonts, and it's going to make a BDF font for me. It should. Actually, I don't know what name it's giving it there, but we'll see what happens. All these options are fine, so I'll hit generate. Yeah, let me cancel that. I don't know why it's trying to do a... Let's try it like that. Oh, that's fine. Okay. It's just saying you couldn't make it as big as you wanted. So... yeah, ignore whatever weird thing I'm doing here. This won't happen normally. We have nice instructions on one of our guides for making these, and I'll include it in my guide for this. Once that's made, you end up with, let's open up a new folder, and I'm going to show you that font there. So what that would generate, if I'd done that right, is this thing here, IBM Plex Mono Medium 24. You can see I've renamed it here JEP, and that's because I've gone in and hand-tuned it. The BDF font is actually a text file. It's human readable as well as computer readable. And I know I've shown some of this before, but I won't get into the hex individual pixel lines this time, but I will show the thing I changed on the colon and the space so that they would kern in tighter, because normally their spacing, since it's a mono font, was a full, I think, 16 pixels wide like every other character, and I wanted those tighter. So if you look in my, how about we'll open this one up in Atom here. I'll make that a little bit bigger. You can see there's the font. I added my tuned for the matrix clock comment so I knew this was different than the real font. And if I look in here, these are individual characters. So here's the space. Like here's the number sign. So number sign starts and ends. Number sign starts then there and ends there. So if we look up at the individual bitmap for space, this D width refers to the spacing after the beginning of the font first pixel before the next one. And I believe by default this font uses 14. So I trimmed this down to 8, which gave me a tighter kern for the next character. And then the bounding box, I think, defaulted, see, something larger than that for the colon. Let's go find the colon. So here's the colon. Yeah, so like a semicolon, and most of the characters here have a 16 value of 16 for the bounding box width. And I tightened that to 13 for the colon and the space. And again, that's what allowed me to hand kern them. So you can see here, it's maybe a lot of trouble to go to, but you get a really nice result. You get exactly the spacing you want, even though it's a mono-spaced font. We're cheating and not mono-spacing the colon. Of course, you could do this in code. You could go into multiple individual labels inside of the CircuitPython matrix display labels library, use separate labels for the different elements, and then get the kerning the way you want. But I wanted to keep that part simple, so I did a little bit of extra work just on the font. And I don't plan on making different fonts for this. This is the one I want for this clock. So it's kind of a one-time effort, and then it keeps the rest of the code very clean. And you can see here, this is keeping up very nicely. My clocks agree on what the time is. And right now, it's in this 6 a.m., 6 p.m. thing. What I'm going to do is, off camera, because I don't want to share all of my passwords and AIO keys and things with the world, but off camera, what I'll do real quick is I'm going to edit my secrets file to a different time zone that's in the PM. So let's see. Right now, it's at Los Angeles, US. So what I'll do is I'm going to go to the Time Zones API. I can share this with you real quick. Let's go to my Firefox. worldtimeapi.org/timezones. So how about we'll go, let's go to Italy. Where are you, Italy? Are you Italia? Are you not here at all? Where did Italy go? All right, let's look at Europe. Oh, it's probably a city. Let's do Rome. There we go. Europe/Rome. Okay, so that's what I'm going to change my secrets file to. Right. So it's restarting now. Right now, it's actually, since I didn't unplug it, it's kind of maintaining the time that was on the clock. So you see, it didn't go back to that red 12 o'clock. This is the time it thinks it is just based on its own internal ticks, which might be accurate, might not, so you can't necessarily trust it. But now it's going to go and, again, try to get online. Let's see. Let me switch over to that Moo window again. There we go. Oh, yeah. So I'm having the fun of it, not necessarily wanting to get on my Wi-Fi. I'll unplug power, actually. Sometimes that seems to, or hit a restart. But when it does get online, it should now go to the red digits because we're using a different time zone. So that's one way that you can test things. And of course, it would be possible to put this into the debug as well, but I like to test it as close to reality as possible. So I wanted to go and check for different time zones. All right, so this should, we'll see. Let's see. Oh, in the chat, Todd is claiming that you can't see my window, so I'm safe. All right, maybe I didn't share all of my passwords with the world. This was the idea behind us using the secrets document, but it doesn't help if you think you've shown it. All right, so yeah, oh, fun. Yeah, I think I'm now going to run into that cycle of my Wi-Fi access point being a little bit far away. Okay, I promise before I do the next one of these projects, I will fix my router that's in here to broadcast Wi-Fi internet. I'll try resetting this again. Let me try pulling power. You can sometimes drive this, like you saw with my battery, you can sometimes drive this off of just your Ethernet, or rather just your USB. But that's only if you're not displaying that many pixels. So let's give it power. You can see now that I've dropped power, it's going to go to the 12 o'clock. And I'm just going to set that there. I will not look at it for a minute. And in fact, I'll close that serial monitor so I don't curse the thing. And if it shows up, and we'll be happy. So I can put that out of the way. And I think that covers it. So let me know in the chat if you have any questions. I know I haven't checked over on... oh, yeah, so 45 RPM says the same. We can't see what you're referring to. Maybe I was quick enough to hide it. I thought it was showing. Let me know if you have any questions about how that works. Side real time tells you what hour of Wright's ascension is crossing your local meridian. It basically tells you the position of the stars. Oh, interesting. Yes, there are a lot of people who know a lot about clocks and time in the Discord, by the way. This is something I knew going into this. So go check out the Discord chat if you want to discuss time and clocks. Okay, I don't think I'm going to convince this one to get onto my access point this way, so I'll give up for now, but I assure you it works. Just have good internet around. And I think that covers it. So let's see, before we call it a day, I will make a quick reminder that you can come and see my workshop tour and behind the scenes talk at Maker Faire Miami, virtual online Maker Faire Miami this weekend. It starts tomorrow through Sunday. My talk is on Saturday, the 15th of August at 3 p.m. Eastern Time. So please come check it out. And I believe that you'll be able to ask questions in advance as well as in the chat. There are moderators. I know the moderating team who are setting up Maker Faire Miami, including the amazing Mario Cruz, are going to be in chats, moderating and guiding these discussions so that we can have it be as interactive as possible. And I think it should be really cool to have it all under one roof, all in one sort of streaming platform. So go to the Maker Faire Miami site and register now, and then you'll be able to get all set up in advance, so you won't be scrambling to do things on the day of the event. So go check that out. And I think that will wrap it up for the day. I will, because I don't like to take no for an answer from clocks, I'm going to give this one more try. I'll plug this in a little further away from some of the meshes and things that stand in the way of my Wi-Fi signal. In fact, let's go to this one over here. You can see I'll hold this way out here and see if we can convince Wi-Fi to come on. And I also want to thank everyone in the chat for hanging out, asking questions. I'll be around a little bit after if you got stuff you want to discuss. I also thank, ToddBot again for the fantastic trinket trigger, proving that CircuitPython is moving into Eurorack in a big way. We've shown the Winterbloom Soul before, so I think more and more synth people are getting their head around CircuitPython, which is pretty awesome. And okay, look, it worked. So now it's 10:57 in Italy. So it did get on my Wi-Fi. I can bring that over. Sorry, you couldn't see that in the serial port because I had to get to a nice place where that's visible. But there is your after 6 p.m. red, and you can of course go in and customize all that stuff really easily. So I think people will have a lot of fun with making their own clocks. And that's going to do it for me for today. For Adafruit Industries, I'm John Park, and this has been John Park's Workshop. I will see you next time. Bye-bye.